Hi, and welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. And we're doing day 2 of the Advent of Code challenge. So, as I said yesterday, this is nothing to do with robotics really, it's just a general programming challenge, but it's good fun, and I encourage you to try and do it for yourself. Today we're looking at day 2, which, as you can see, is just been released a few hours ago. So I'm going to open this up. Now, I've already read through this. And essentially, what we need to do is take the grid of numbers here and process it row by row according to a number of rules. Either all the numbers are decreasing, 7, 6, 4, 2, 1, or they're all increasing, like 1, 2, 7, 8, 9. That counts as safe, or at least doesn't disqualify it. There's also another rule, which is that two adjacent levels have to differ by at least 1 and at most 3. So you can't have 7, 7 or 4, 4 in a row. That disqualifies it because there's not enough of a level jump. And is there one that's too large here? I can't see any that are too large, but that's something that we'll need to account for. So as with yesterday, I'm going to open up the Advent of Code project and going to start the day 2, cargo, new, day 2. Then I'll open it up so that VS Code can understand the project and start to run it properly. Then we'll run this and we've got the hello world printout. So now let's create the folder for the puzzle input. And again, I'm going to create a test.txt. Then I'm going to input this grid into it. That's our puzzle input, and just like yesterday, we can now read that out of the file. Learning from the mistakes of yesterday, we're immediately putting the right path in, and we're also using a format string. Now we can run this and we get the puzzle input, just like that. The next step is to parse this. I want to create a readable format from it. Now, because we're parsing it and we're looking at each line, we're going to contain each row in a vector. Then we'll contain the whole grid as a vector of vectors. So I'm actually going to start using a structure for this, just to make it a little more convenient to keep things in different functions. So I'm going to declare a struct, and we're going to name it after the puzzle. So because it's reports, we're going to call it a report grid. Now, report grid will consist of a grid, which is a vector of vectors of I32. That is it, and now we can start implementing methods on report grid. First, I'll implement, or rather, I'll create from str for report grid, and then I should be able to autocomplete nope, I can't. Okay, so this is our new parse function. Instead of using okay, so we can look at the documentation for from str. It wants a type error. And it should return this function signature. self.error, and it's asking for a definition of which type error is. So I'm going to put type error is, I don't think we have a specific error type, so I'm just going to declare one. Now it's complaining because the function is not returning anything. So I'm going to give it an error. And now it's happy. So with this syntax, we can instead do let grid is report grid dot from str, and then pass it the puzzle. Although it's not a dot, it's double colon. There we go. And at this point, I'm comfortable unwrapping because it's the main function. I just want it to it's saying that I need to derive debug on this report grid error. So I'll add that in. And that means that when we unwrap it, it will be able to print a more useful error message. So what happens here is if I fail to parse, it will panic in the main function. Normally you want to avoid panics at all costs, but because this is the main function right at the start, if I can't parse the puzzle, I can't do anything else, and I want the program to just exit and give me an error. So in this case, I will unwrap. I think it's justified. What I can do is instead use an expect and then pass an error message, enable to parse input puzzle, which is slightly better but has roughly the same effect. So it's up to you what you prefer to do. Let's start writing that parsing code. So we're here and we want to run line by line through the string. So I'm going to change this to puzzle. It doesn't need to be, but that's what I'm going to call it. I'll create a vector, and then for each line I'm going to create a new vector and push it to the grid vector. So that will need to be mutable. So for line in puzzle.lines, parse it as a series of integers. So I can just do line.split whitespace. Then I can filter map it by i32 parse, and then collect it into a vector. Now it will tell me that it needs to know what type of vector to do. Oh, I can't do that. I can't do an i32 parse. In x and return x.parse. Is that okay? So because it might return a result, then I need to check it's okay. That transforms it into an option if it successfully parsed. Collect tells me that it needs type annotations. I could give it type annotations, or what I can do is let it infer type annotations by pushing it onto the grid and then returning returning a report grid with the grid. And because it knows what type the report grid is, what vector type it has in it, that means it's able to infer what kind of vector to collect it into, which means that I don't need to put those type inferences there. In fact, I might even be able to remove that type inference. Yeah, so I don't need to specify that it's an I32 parse. It will just do it because I specify it's an I32 here. So at that point, we should have a grid. Something that is useful to be able to do is print this out. One simple way to do that, we could define the code for just printing the grid out, but another way to do it is just to derive debug. And by doing that, we can use a debug format string with the grid. And then we have 76421 on the first row, which is correct. And it has a series of vectors just like that. So that's our structure. That's our puzzle parsed into a structure that we can implement methods on. Now, we never use this error function, which is a bit weird. So we're just removing any lines that don't parse and ignoring errors. What we could do is instead return an error that it was unable to read it, which might be a good idea. But in this case, I'm just going to remove this error case so that it's an empty enum and it won't complain that the case isn't hit. Which is another reason that we can use expect. We actually will never return an error result from this function. So in fact, we can just unwrap, but I'm going to keep it as it is for now. Okay, so that's the parsing step complete. Now we want to actually calculate the number of reports, the number of rows that satisfy the rules. So I'm going to implement report grid. I'm going to have a part A function, which is going to take self, and it can be immutable because I shouldn't need to change the structure in order to count things on it. And it'll return an I32 as well. In fact, more correctly, it should be a usize, but I think I32 is fine. So at this point, we want to iterate over all the rows. For each one, check if it satisfies the rules. So we'll do self.grid.iter. For each one, we're going to filter it out if it doesn't match some rule. So for that, I can make a function satisfies or is safe. There we go. And the is safe function can take a report, which is a reference to a vector of I32, and will return a bool. Or more correctly, will return an option. I'm not sure if filter works on... Oh, it does. It works on bools, so we can just directly return a bool. So for now, I'm just going to return true. I'm going to say they all are true. So I should be able to filter by is safe because the filter is checking for each row and it's executing the function on each row. And then I can return count. Now, because count returns a usize, I will in fact convert this to a usize. I'd rather just convert it to a usize than explicitly convert it to an I32 for no reason. Okay, we'll make that a report. We can filter by... okay, so we need to pass the contents of it. All right, so we need to take the report and execute is safe on the contents of that report. Then it's happy. So it's because filter is receiving a reference to a reference of a vector rather than just a reference to a vector, which is what I thought it was taking before. So at this point, it just directly returns the count because there's no semicolon blocking it. We can do our usual style of let count is count and then return count. Now that would be our part A done if we had implemented the is safe check. But let's run it now and see how many rows it says are safe. So we're going to change this printline function. We're going to make it part A, and then execute grid.part A. It should give me, I was expecting 5. Oh no, there are 6 rows. So yeah, because I've said every row is safe, it's given me 6 rows are safe. So at this point, I can now focus on my isSafe function. And remember the two rules that we need to satisfy. The levels are either all increasing or all decreasing. The other rule being any two adjacent levels differ by at least 1 and at most 3. So we need to get the difference between each 2 points. You also need to make sure that they're all running in one direction. So what I think I'll do is create a vector of all the differences, and then I'll check that either all positive or all negative, and I'll check that none of them are above a certain amount. So let's get the differences. The differences are... Don't know why I did that. Okay, so report iter zip with report iter skip 1. So what that'll do is take the array and zip it with the array moved down 1 slot, so that it's the first compared with the second, then the second compared with the third, and so on. And because zip will only work as long as there are 2 entries to compare, it won't run off the end. So at this point, we can take the difference by mapping the tuple of A and B to A minus B. And then we could collect it into another vector. So I don't want to type specify here. I'll type specify here that it will become a vector of I32. And it's unhappy because I renamed report to have an underscore. And that's better. It's now happy. I now have a list of differences between them. So first, let's check that they're all increasing or all decreasing. So we'll iterate over each. We'll iterate over the differences. So here I'm just saying that it is positive if the second difference minus the first difference is greater than 0. So now I want to check if that's true for all of them. Actually, I might be able to do that with a .all in some way. Report.iter.all. So this predicate says, or it needs a predicate. So it needs a closure that returns true or false. So I'm going to take the difference. Oh, actually, I don't need to do the subtraction. I've already done it by taking the difference. So I can take the 0th element and I've done A minus B. So this would actually be negative. So if it's 97654, then it'll be 9 minus 7 is 2, and because 2 is greater than 0, it becomes negative. I could actually flip this around to make this a bit more make a little bit more sense. So it is positive if the difference is greater, the first difference is greater than 0, and now I need to check that they are all positive or all negative. So for that, I'll take the difference and I'll say take that difference and check if it's greater than 0. But not just that. That needs to be true. That needs to be the same as what we checked for the first difference. We want star x because we want the context of x. Closure is expected to take 1 argument, but it takes 0 arguments. That's not true. Oh, I needed to save it. Okay, now it's happy. So we can immediately return. If it's not all one way, then return false. Now we can do our second check. If any two adjacent levels differ by at least 1 and at most 3. So I can again use this all function. I can say differences.iter. I'm going to take the x and check whether x.abs. Actually, I'll map it with abs so that I don't have to do the abs twice. So I'll take the x and do x.abs. I don't need to use the star there. And then I can check whether that is less than or equal to 3 and greater than or equal to 1. So that checks that the difference is at most 3 and at least 1. So I can call this level changes safe. And then I can return that. Now our isSafe function should be complete. And if I run this, it should give me 4. 2, that doesn't seem right. Oh no, 2 reports are safe. So that's exactly what we expected. So there's an increase of 5 and a decrease of 4, increasing but not decreasing, neither an increase or a decrease. So if I were to remove that level changes is safe part and just make it true from there, it would give me 4 because, oh, it gives me 5. Neither an increase or a decrease is also a check that the level has increased enough. So these are where the increase or decrease are too big, and this is where it's not big enough. So that means if we ignore that rule, then the safe one is safe, the 2 safe ones are safe, and the ones where the increase is too big or too small are also counted as safe. So let's put that back in. And we're now ready to run on the real puzzle input. So let's get the puzzle input and copy and paste it. That'll be into input.txt. Save that. So that's 1,000 lines long. And now we're going to change this. And the answer is 624, apparently. Advent of code agrees. Excellent. That moves us on to part 2. But just quickly, before moving on, there is a useful tool called Clippy. Which is a way of formatting Rust code, as well as running checks. Although I'm not sure how to run it, so let me Google that quickly. So I need to do my check on save command. I will just edit the settings by hand. Now that should work for my user, and I just need to install it as a tool. So I can run cargo install Clippy. Oh, and apparently that doesn't work. I have to do rust up component add Clippy preview. Interesting. Ah, already added. So I think it's already installed by default. And I think this is Clippy telling me that I don't need to use the star here to dereference report. It will coerce it because it understands is safe, takes the and vec. So I don't need to tell it to do that. What else do we have? This creates a new object instead of a slice, so I can convert this to a slice. That works. And then I can use a range inclusive function. So it's telling me I can use this code snippet. So this creates the function from 1 up to and including 3, and checks if that range contains x, which is the same check exactly. And then we have it. That's all the Clippy recommendations. We'll just run it again to make sure we get the same result, and 624. So with that little detour out of the way, let's continue to part 2. Interesting. So we are now allowed to tolerate up to 1 unsafe check. So that should be pretty easy to implement with what we've got. One part is that I'm going to pull this out into a helper function. It doesn't need to be in there anyway. That was just to localize it to where I'm using it. But as I now want to use it for part B, I'm going to move it outside. So let's use part B. Let's create a part B function. And we're going to change is safe to count safe. That doesn't quite work with how I've coded things. Okay, we'll change is safe to have a second parameter, which will be called unsafe allowed. That'll be usize. Now we're going to check what the differences are. So let new unsafe count is 0. We'll use the unsafe count plus equals differences dot iter dot filter, where this condition is not true, because that would make it unsafe. We don't need brackets there. Dot count. Now at this point, if unsafe count is already greater than unsafe allowed, we should return early. We can comment this out. And again, we can do unsafe count plus equals differences dot iter. We'll keep the map, and then we'll count where this is not true. And we can do that with just exclamation. Sorry, that's not a count. That is a filter, which we follow up with a map, with a count. And we don't need an X. Now we don't need that. We just need to check whether unsafe count. Unsafe count is less than or equal to unsafe allowed. That will return a bool. Let's check it by using isSafe0. That's our part A, and then our part B becomes isSafe with 1. Now we can check this. We can run it against the test input and check we're getting the same result. Oh, that is not allowed. Start x greater than 0. We can either borrow 0 or dereference x further. So I think that makes more sense to dereference x. And run it again. And there we go. So part A is still coming up with 2. So that's fine. That gives us the same result again. But part B should be 5. Oh, 4. It should be 4. And we're getting that it's 6. So something is not allowed. Something is not right here. You can auto format with Clippy installed, by the way, and it'll space these out onto separate lines, which is a more normal way of spacing out Rust code. I have a bad habit of putting them all on the same line because I can't be bothered to separate it properly. So at this point, we've still got our differences. That should be fine. We're checking whether it's positive. We know that works. And then the unsafe count is so we are allowed up to 1, which is what we've coded with greater than and less than or equals. Okay, I'm not seeing what's wrong by reading the code, so I'm going to start littering some print statements about. Write the unsafe count there and there. And I'll also separate it out by looking at what the current report is. So I'll use the debug here. Let's remove part A. We don't need to see part A's results. And we'll run that. Okay, so here we can see that they're all decreasing. So this is already safe. The unsafe count here is 1, which is allowed. The first and last are safe without removing any level. This one is safe by removing 3. So it goes up 2, down 1. This is unsafe because there is too large a jump from 2 to 7. And if you try and remove either 2 or 7, it doesn't make a difference. It's still unsafe. That's not coded in what I've written. So essentially, I've misunderstood the problem and written something that doesn't make sense. Okay, so I can think of a reasonable way to write this. I'm actually going to undo all of the unsafe count checks and write a new function. So instead of collecting together all the differences and checking the rules one at a time, I'm going to make it so that it checks as it goes, such that if it encounters a data point where one of the rules fails, it will try to skip that data point and check the next one instead. And if that also fails, then the report fails overall. So let's create a new function is safe dampened. Again, we take a slice of I32 and return a bool. So at this point, our part B should be is safe dampened dot count. And we can rename that part B. That should be that. Okay. So at the moment, is safe dampened. We can return true to make the IDE happy. There it is. And now we're going to not sure of the functional way to do this, so I will do the more manual method. And I've forgotten, it's enumerate. So I need to do for index val in report.enumerate. Enumerate. I think I do report.iter.enumerate. So these are the right way around. Index is usize, val is a reference to an I32. So now what I can do is other is report index +1. That is not guaranteed. So we need to check whether that exists. If actually what we can do is take up to report.length -1. So we don't need to do the if statement. It will give me an iterator over the first n-1 elements in report. So I've got my other. It's guaranteed to have the right index because of this take. Even if it's a one-length array, then take will take 0 elements. So nothing in this for loop will execute. So this is safe to run. So now that I've got that, I can check the first rule applies. Check if positive. So I'll create a let mute positive is true. And let mute unsafe count is 0. But this isn't quite true. Because when we want to skip an element, we'll need to skip out the middle element, which means we'll need to add 2 to the index. So instead of doing this take, unsafe count, we'll do let other index is index plus 1, 1 plus unsafe count. If other index is greater than report.length, return true. Or we can just break and then return true at the end. Oops. Okay, so now our index check is safe again, and we're also skipping 2 if we've uncovered 1 unsafe count already. So now we can use other index to index into the report. Now we can check whether it's positive or negative. So if the index is 0, which is our first case, then our positive needs to be other minus val greater than 0. So that is always allowed. Else, if other minus val greater than 0 is not equal to positive, then the rule fails. Increment unsafe count plus equals 1. And then we need to recheck everything. So I'm just going to leave a to do here, recheck everything. What I'm thinking I can do is pull this out into a function to check whether a rule passes or fails. But I haven't got to that point yet. So else if block can be collapsed. Sure, I'm going to leave it as it is for now and deal with the ugly yellow underline. So if this is not the same, then the unsafe count increases, which means that the next index will be checked instead. We also need to trigger a recheck, but we also need to check level change within range. So we can do let's change is val minus other dot abs, and then let change safe is 1 to 3 dot includes contains the change. I think this needs to be reference. Yes. Now, if not change safe, then we need to increment unsafe count, and then to do recheck current. But what we also need to do is check the failure case. So if unsafe count is already greater than or equal to 1, then return false. And again, down here. Now, what would be really nice is if I could just go back one iteration in the loop so that I don't need to repeat myself, but I don't think that's feasible. So what I'm instead going to do is create a couple of closures that check the rules. So let's check pos is we're going to give it the index, first val, and the other. And this will, if index is 0, return true. Else, if other is not positive, then return false. In fact, we need to just return false, because then we can handle the unsafe counts below. Else if can be collapsed, so it will be, I assume it's saying we can put this onto one line and then just return false. Yeah, so if it's the first index, we need to check whether it's positive or not. We need to give it a type. I think if we use the type, it will infer the type. So that's our first closure, and then our second closure is check level. And we actually don't need the index for this one. So I'm just going to take val and other and return the change and whether the change is safe. And I can just use that. Now, again, it's saying it needs type annotations. It can't figure out what it's doing without type annotations. So what we can do here now is if check pos of index, val, and other. If unsafe count is 0, then increment it. Actually, we can just increment it either way. If not check level, val, and other, then unsafe count plus equals 1. Then we can recheck it. Okay, so if unsafe count has increased, let mute dampen. So I'm instead going to do dampen is true. But we need to check if dampen is true here. Okay, so but that's okay because it can fail both rules and not fail overall. So if dampen, then increment unsafe count, check unsafe count, If it didn't work, then check it again. Except instead of setting dampen, we just return false because it can't tolerate another failure of the rules. At this point, we should be able to get rid of all of this. And I think that's ready to try. Let's give it a go. Failure because it cannot infer type. Okay, so we really do need to give it the type annotation. It didn't infer them. Val, well, we can just call this star, and it takes an I32, and other is an I32 as well. And then this one it managed to infer, strangely. Check pos is unhappy, cannot mutate immutable variable. It's not. I'll type annotate this to figure out what's going on. Okay. That wants star val, and it wants star val. And it still thinks I'm trying to mutate check pos. Don't really know why. I guess it thinks check pos is mutable, but it's not. It requires mutable binding because it needs to borrow positive. Okay. That's why this one is complaining and the other one isn't. This one is mutating positive and this one doesn't mutate anything. All right. So we do need to make that mutable, which fixes everything. It is easy with Rust to just do what the compiler tells you. Often that works. The compiler does have good error message and good advice, but I would recommend trying to understand why it's saying to do something. In this case, I couldn't figure out why this needed to be mutable. I could have just followed its advice and made it mutable, but I worried that I was somehow overwriting the function when I shouldn't be. So it is off, like, try and understand why you're changing something. Now we've got a whole bunch of commented code. Let's get rid of all of that. Okay, let's try. Give me 5. That is not what I wanted. 2 and 2. Yeah, so that's not working. That dampening hasn't done anything, essentially. It is being used, or it would give me a warning that the function's not being used. So yeah, something is going wrong in here. Unsafe count is 0. So let's try, is safe dampened on a test case? One that we know from the test text is wrong. So I'm going to configure tests. Oops. Mod tests. And then this one will be a test. And we're going to function test that is safe dampened works. Don't need to pass anything. My test case will be and then I need to assert that it is not safe to dampen, or rather that it is safe to dampen inputs. Okay, now this will return safe because there's no rules failing, but it means I can show that cargo test does something. Okay, test result, okay. So let's take so this test scenario, 13245, this is made safe by dampening. Let's add this in and test. Okay, so now we've got that, I can start adding in print statements and figuring out what is going wrong. So if dampen, then let's make sure this gets hit first of all. Dampening an error by skipping. This needs to fail. Wait. This test case should be... It should be not safe unless it's dampened. And that says that's the case. Cannot find function. Oh yeah, so we need to use super. And it's running 0 tests, so that's why it says it's safe. Okay, cargo test. There we go. Test result failed, and it failed because is safe dampened works. It does not work. Assertion failed. Is safe dampened. Okay, so that's what I'm expecting. I just didn't have my test set up correctly. So I can keep this in. That's fine. I want this to be true, and it currently isn't. We are dampening it. We say we're dampening an error by skipping, and we only say it once. So we only dampen once. Okay, so we don't actually set up other again. So let's do that. And run it again. And now it works. So all I needed to do was reset other up, which I forgot to do as an extra step. I can now remove this print line. We've got a test that checks something works, which is cool. And actually, I can just format the document and it should work. Why are you upset now? You stood from str. Okay, I don't know why it complained before, but it seems to be happy now. Okay, so we're running on test. Let's now cargo run. And that is saying 4, which is what we're expecting. Okay, so we can now run it on full input. And we're getting 641. 41, submit. That's not the right answer, it's too low. Okay, interesting. That means that it is not dampening enough by the sounds of it. So it's probably best to try and think of some edge cases. To make sure that it's working. Okay, let's look at input.txt for some edge cases. So that one looks fine. This one is decreasing, so that's fine. Nothing immediately obvious in here. 3, 1. This is probably the wrong way to go about it. So instead, let's try and think of where the dampening is going wrong. So because 641 is too low, that means that there should be more cases excused than I'm allowing for. The dampening is not dampening enough, I guess. So let's check a few cases. We'll check we use this number set and just keep changing it around. So let's start with 3, 1, 2, 4, 5. We'll check that that is excused. We'll check that too large a number on the end. Check that that's excused. Let's run those and see if there's anything already. Failed. Something, one of those two edge cases that I just described isn't being dampened. And it should be. Those two edge cases should both be fine. Okay, so actually, in this case, the first one is if we remove the first one, then it should work. So this should be correct because skipping 3 makes it valid. But we check positive, assuming that the first couple is okay, and it's not. Okay, what I think I'll try and do is go about this a different way. I've been trying to do one pass of the vector, but if there is a clean way to do it, I'm not seeing it, so I'm going to change to a different way. I'm going to do multiple passes of the same vector, having removed an item. So my function is safe dampened 2. We'll take a report of I32s, return a bool. Okay. Iter.copied, that's what I want. And then this collapses to Dr. Vec. Oh. To Vec. There we go. That's an easier way to clone it. So all I'm doing is taking a copy of the report right now. Now I want to find the index at which the rules first go wrong. So I think I can do a find on that. Iter.find? Yes. And this takes a closure that returns true or false. Right. So actually what I can do is use is safe. Except is safe returns a bool. Searches for an element that satisfies a predicate. Okay, so what we're going to do is search it as we go. And because we don't need any mutable variables or unsafe counts, it should be easier to code. So let's first copy these closures over. So mute check pos doesn't need anything. We'll pass whether it is positive or not. I'll come back to that. I'm not entirely sure how to code that off the top of my head. Check level will be the same. Right, I'm going to create another closure, which will take what I believe is the index and the current value. And return, I'm not sure. Find where it satisfies. Okay, so I want to make it true. Now I'm going to find the point where the rules fail. Uh, 20%, that should be fine. So, check rules fail. Consider wrapping this function in a closure. So it wants a reference to that. Okay, there we go. So I'm now unwrapping it into an index and a reference to an I32. It's a reference to a tuple containing those things. Now, if the rules fail, then there will be something in the option. So what we can do is match index. In fact, we can match directly on this. In the case where I get none, that means it's already safe. I can just return true. In the case where it is sum of an index, then I need to do some further processing. I need to try removing it in both cases. So let port clone left missing is port clone dot. In fact, port dot iter dot to vec. Directly do to vec. So I want to remove position at index. Index is a usize. So I'm instead going to take index and something, which I don't care about. Okay, so we're going to remove the index and let mute report clone right missing port.to vec. report clone right missing dot remove index plus 1. Now we need to check that this is within bounds. Check index within bounds. If let's sum, I don't care, equal to check rules fail. Okay, so if it fails twice, then return false. If, and we can do the same thing here, let's sum on right missing, return false, otherwise it's true. Now I want to move these down so that I can do an early return. If index is report.length -1, then break, return true. Okay, so if it's okay with the last element of the array missing, then return true straight away. Otherwise, if there is another element to try and remove to check it, then do that. Okay, so what we can do with this is check the rules fail by let other is we can copy our other index logic. So let other index +1 plus unsafe count. Don't need that. Simply index +1. If it's greater than report.length, because this is a closure, we are capturing report, so that is fine. But instead of breaking, we would return true. And let other is that. Then we want to return check pos of val and other, and check level of val and other. Expected 3 arguments, found 2. Right. So we need to check that it's going in the same direction for the entire array, except at the moment our only knowledge is of an element within the array. Okay, let's let find bad index. It's equal to a closure that takes report and I32. Let mute positive is true. It doesn't really matter. Then we're going to do for loop over it. Right, so we'll take all of this. And then remove all the dampening logic. Okay, so for index val in report iter enumerate, if index is 0, then positive becomes val other minus val greater than 0. Otherwise, if other minus val greater than 0 is not positive, return index. So this is the point where it goes bad, according to this logic, which I'm not entirely sure is true, because in the case of 312, we need to index is 0, so we're setting this as negative, and then the next go around index is 1. So at that point, we are checking the wrong thing. So yeah, this logic doesn't work. We actually need to kind of go back 1 almost. We need to check the current and the one before it rather than the one after it. Does that work? I think that works. Let's try that. Okay. We don't need this. Okay, so the first point where it becomes a change from positive or negative, we return the index. We check the change, and the first time that change is not within range, we return it. So we can get rid of those, and we can get rid of the closures. We don't need this clone. In fact, we can get rid of the whole line. And it doesn't like this. Why not? Expected use size found brackets. Yeah, we should actually return a sum to say that we did find a problem. Okay, and then if not, we return none. That's all right. Now, oh, I got rid of the other logic. Okay, copy that back in. Grab that. Doing unsafe count. We're checking it against the length. This check isn't actually right. The report.length -1, I think. So if it's greater than or equal to report length, then it's off the end. So ignore. Then, yeah, we can move this onto the line, collapse it down like it said before. Okay, so we've got our other. We're checking the positive, we're checking the change. And at this point, I don't think we need check rules fail. Instead, we're doing let index is match find bad index on report. None, then it's already true. And if it's something, then all of this stuff applies. I think we've already got that to do, so I'm just going to copy this branch. Okay. This is no longer true. Now we want to change this to find bad index of report clone left missing. And this one will be report clone right missing. This is no longer returning a tuple, it's just returning the index. If dot is sum, instead of using an if let binding, because we're not using the value, we can just check it is sum. And now we just need to reinstate that logic where we're checking the one previous rather than the one forwards. So we're actually going to move this to the top. We're going to remove index and check it. Then we're going to do if index is 0, then it's okay. Although this doesn't count the case where there's 2 errors. No, it does count the case where there's 2 errors because this would catch it. So I believe that's right. Now we can do remove index -1. Find bad. Okay. Let's see how badly this fails. We're going to test it. I never set these up, so I'll just remove them and I'll copy this. Down to here is safe dampen 2 work. Under 2 and under 2. I'll go test. Failed. Both failed. Comment this out just so I can see is safe dampen 2 failed. All right, so let's try doing some print lines on it. Get rid of all of this, we've copied it. Get rid of this. Okay, find bad index says for a report, see if it's positive. Get the 2 values, so that's 0 and 1, 1 and 2, 2 and 3. If it's the first index, we need to set positive, so we set the positive. Otherwise, we check whether it matches the existing Boolean flag of positive or not. If it does not match, then we return some at that index. Okay. Found bad index. Index. Print line. Removed index. Report is now report clone right missing. Oops. And left. Okay, so we removed removed current and then removed previous. Hang on, what's our test case? Oh yeah, okay, right. So we removed the current index. The report is now 1245, which is fine. Okay, so we actually need to check if it's none, then return true. Because we found a test case that passes if we remove this index, so we need to check that. I don't think this is right. I'm worried about that. But let's try the test again and see what it says. Okay, it's now happy. So I guess that logic is okay, but we'll try it. We'll try it on the full input, which means part B needs to be changed to run is safe dampen 2. Run it. We get 1,000. That doesn't seem right. I'm going to go ahead and assume 1,000 is wrong. I'll put it in, but that's every test case passes. Yeah. Yeah, so there's something wrong there. Okay, so the test cases worked. We can try and do some more edge cases. We can check that valid ones still work and that 2 with invalid don't work. Let's try 1, 5, 8, 9. That's 2 jumps of more than 3, which means it should fail. So it should fail, do an exclamation, test failed. Okay, so it's saying it's safe, but it's not. So let's comment out these test cases that we don't care about. And what happens is we found a band index at 0. The report is now, it's now 59, which apparently makes us return true. And I think it's that 0 that makes it wrong. Okay. So what's happening here is that if the index is 0, we've tried removing it, and we want to try the element before. But what we could do is just try the element afterwards. So if index is 0, then we're going to add 1 instead. This is now no longer left missing or right missing, but actually we could always make it +1 In fact, that's kind of funny. Let index equals index dot saturating sub 1. So that means if it's 0, if index is 0, but that let binding will be let mute index is index. If index is 0, then index equals saturating sub. And then add 1. I'm not really sure what I'm doing here. I've gotten lost in the code. Basically, we always want to check 1 back unless it's 0 already. Failed. Okay, I think this default case should be false. Maybe that's what the problem was all along. Okay, that actually works better now. Let's try a run. Do we get something more interesting? 648. 641 was too low, so 648 is promising. That's not the right answer, it's still too low. I think I've been recording for a long time, so what I'm going to do is stop there. I'm going to debug it offline. I think the solution is very close, and I want to figure out what's wrong. So I'll debug it offline. On tomorrow's video, I will show what the issue was before continuing on to day 3. If I had more left of the problem, I would just roll it over to the next day. But in this case, I'll try and fix it offline and report back in the next video. So thank you for watching. I'll see you tomorrow for a solution and day 3. See you then.